Bismillahirrahmanirrahim. Good morning. Assalamu alaikum, student. Hope you all fine there. May Allah bless you all. May Allah keeps you safe and you will remain healthy. Today is Friday, 18th December 2020. Today the topic is real numbers. Today we are going to revise the exercise 2.1 and 2.3. Before revising these exercises, we will revise our topic, which is real numbers. Before revising the real number, we recall the following sets before giving the concept of the real numbers. First numbers are the natural numbers. The natural numbers are the numbers 1, 2, 3 and up to so on, which we use for the counting contain objects are called the natural numbers or positive integers. The set of natural numbers is denoted by n. It means natural numbers set is equal to, it is represented by n, and we include all the counting numbers in this set, which are 1, 2, 3 and up to so on. So the natural numbers are those numbers which we use for counting. When you ever go to school or get an admission in a playgroup or the lower classes, your teacher taught you the counting numbers 1, 2, 3, 4 and up to so on. So all these numbers belongs to the natural numbers. So all the counting numbers are called the natural numbers. Now we are going to discuss about the whole number. Whole numbers are, if we include 0 in the set of natural numbers, the resulting set is the set of the whole numbers, which is denoted by W. If we add 0 in the natural numbers, so it becomes the whole number. So whole numbers are those numbers which starts from 0. So 0, 1, 2, 3 and up to so on, all these numbers are called the whole numbers. Now we are going to discuss about the integers. The set of integers consists of positive integers, 0 and the negative integers. 0 is the neutral number and there are two types of integers which are positive or negative. So the set of integers is denoted by z. So it means if we write the integer set, it represented by z, and in this set we include the negative numbers and 0 and the positive numbers. So negative numbers are called the negative integers, 0 is a neutral number and the 1, 2, 3 these are the positive integers. So now we are going to revise the set of real numbers. First we recall about the set of rational and the irrational numbers. The rational numbers, all the numbers of the form p over q, where p, q are integers and q is not equal to 0, are called the rational numbers. The set of rational number is denoted by q. Here is the set of rational numbers. The numbers which are written in the p over q form, for example 4 by 3, minus 3 by 4, 7 by 5, etc. All these numbers are the rational numbers. So the rational number is denoted by q. The set of rational numbers is represented by q is equal to p over q, such that p, q belongs to integers and q is not equal to 0. So in this set of numbers, q must not equal to be 0. So all the p over q form numbers are called the rational number, which is represented by q. Now we are going to revise the irrational numbers. The numbers which cannot be expressed as quotient of integers are called the irrational number. The set of irrational number is denoted by q prime. So irrational number is represented by q prime, in which the x such that x is not equal to p over q and p, q belongs to integers and q is not equal to 0. For example, under root 2, under root 3, under root 5, pi, and natural logarithm base e, all are the irrational numbers. So now we are going to revise the definition of a real numbers, which is the union of the set of rational numbers and irrational numbers is known as the set of real numbers. If we combine the rational and irrational numbers together, they form the real numbers. So for example, real number is represented by r. Here is the q, which is represented by rational number, and the union, and the q prime, which is represented by irrational numbers. If we combine and get union of these two sets, the resulting set is called the real numbers. Hence q and q prime are both subsets of real number, and q intersection q prime is equal to 0. If we take the intersection of rational and irrational number, the result is 0. It means resulting is empty set. So these are the definitions of some numbers. Now we are going to revise the decimal representation of rational number. So here are the rational numbers. The decimal representation of rational numbers are of two types: terminating and recurring. Terminating are those rational numbers. Here are the definition of terminating decimal fractions. The decimal fractions in which there are finite number of digits in the decimals part is called a terminating decimal fraction. For example, if here is a fraction 2 by 5, if we divide 2 by 5, its result is 0.4. So after the point there is a number of digits are finite, we can easily count that after a point there is only one digit. So it is a finite number of digits, so we can say that this fraction is terminating decimal. And if we divide 3 by 8, the result is 0.375. After the point you can easily count the number of digits. There are 3 digits, so we can say that it's a terminating decimal. Now we are going to revise the recurring and non-terminating decimal fractions. The decimal fractions which is non-terminating, in which some digits are repeated again and again in the same order in its part, is called the recurring decimal fraction. For example, if we divide this fraction 2 by 9, if we divide 2 by 9, the answer is 0.2222 and up to so on. As you see that the answer is continuously going on, and after the point you cannot count the number of digits. So these are the same number of digits or same pattern of digits, so we can say that these are the recurring decimal. If we divide 4 by 11, so the answer is 0.363636 and up to so on. So we can say that there are number of pattern the same 363636, the same number of pattern is repeating again and again, so it is a recurring decimal fraction. And now we are going to irrational number. Irrational number, it may be noted that the decimal form of an irrational number would continue forever and never begin to repeat the same block of digits. In irrational numbers, the irrational number are two types. It's a non-terminating or non-recurring. If we take the square root of 2, the answer is 1.41421356 and up to so on. As you see that after the point the number of digit is not repeating and the division is continuously continuing, so the it is called the irrational number, and pi is equal to 3.141596256 and up to so on. So this value shows that after the point the number of digits are not repeating and the division is continuously continuing, so it is a pi is a irrational number. So these are our irrational numbers. So these are the some definitions which is very important in this exercise. So you will revise and learn all these definitions to understand the exercise 2.1 and 2.3.